What would you say if I told you that there is a frozen galaxy drifting through the universe as a living fossil? For billions of years, the James Webb Telescope has now discovered such a living galaxy fossil. This galaxy has not formed new stars for billions of years, yet it still exists. What is this astronomical wonder really about? A fossil galaxy is a galaxy that consists mainly of older stars and has not formed any new stars for billions of years. In astronomy, fossil galaxies are considered to be remnants from the early days of the universe, providing scientists with fascinating insights into the developmental history of galaxies and the early universe. Usually, such fascinating fossil galaxies are found at the center of huge galaxy clusters, where they may have been left over from merging galaxy clusters. Nevertheless, these peculiar galaxies raise questions. Why did some galaxies freeze and virtually stop growing very early after their formation? And why are these galaxies still active in their own way? These galaxies have hardly changed their shape and composition since the early days of the universe, making them witnesses to an epoch about which we know very little so far. The James Webb Project should finally provide us with valuable insights into the earliest history of the universe. Since the launch of the telescope, we have been surprised again and again. The telescope is showing us scientific wonders by the dozen, and the list of cosmic curiosities is getting longer and longer. We still don't know why and how galaxies formed, and we know very little about why galaxies have been clustering together more and more as the universe has evolved. Research is currently focusing on very old and distant galaxies that date back to the early days of the universe to finally understand the true evolution of matter. The fossil galaxy that the James Webb Telescope has now discovered is another special case in the list of discoveries. The galaxy formed extremely early and widely for evolutionary steps that take billions of years for other galaxies. This galaxy took only a fraction of that time. This explosion of star formation is what astronomers and cosmologists call a starburst. In a short period, the galaxy produced billions of stars, forming a perfect elliptical spiral shape. Then, star formation in the galaxy practically froze, and since then, this galaxy has hardly changed. It's considered a scientific miracle how these beautiful galaxies can continue to exist despite the stagnation in star formation. It's probably due to the distribution of gases and the effects of dark matter and dark energy that a galaxy becomes a fossil so early in the evolution of the universe. However, the effects of dark matter and dark energy on the formation of visible matter and galaxies are still insufficiently understood for scientists to make clear statements about the true nature and dynamics within fossil galaxies. The galaxy fossil NGC 1277 in the Perseus Galaxy Cluster is remarkable. Isn't it incredible that with instruments like the James Webb Space Telescope, we will be able to analyze objects millions and even billions of light-years away from us? Thanks to its unique infrared spectrometers, the James Webb Space Telescope can capture light in wavelengths that are hidden from the human eye. Webb collects the faintest traces of light and then converts them into images that we can perceive. Thanks to this technology, scientists can now see through clouds of cosmic dust for the first time. Cosmic dust is a common phenomenon, and ultimately, all matter and all galaxies in the universe are made up of dust and gases. The dust in space can be so dense that telescopes like Hubble often fail because of impenetrable walls of dust. What was hidden behind them remained in the dark for science. Infrared light can penetrate dust clouds, and so Webb can also turn these light trails into images. This is how we now see areas of the universe that remained hidden from Hubble's eyes. Hubble was already a milestone in space exploration and was able to discover the galaxy NGC 1277, which is about 220 million light-years away from Earth. Despite its limitations, this galaxy is another living fossil from the early epochs of the universe. The stars in NGC 1277 are all very old. Imagine a galaxy in which there are almost only ancient stars, a composition of beauty, form, and functionality that has only undergone no significant further development for billions of years. The vast majority of stars in this galaxy are about 10 to 12 billion years old, and as it stands, these stars are far from reaching the end of their lives. By comparison, our Sun probably has a total lifetime of only about 9 billion years. It's strange that this galaxy has produced a large number of extremely long-lived stars. Scientists would love to know what processes led to galaxies developing into beautiful and star structures in double-quick time, and they would like to know whether all galaxies in the young universe developed in this way. The starburst theory is currently the most popular way of explaining the unusually old and well-developed galaxies that Webb discovered. Explosive developments could be the reason why, 200 or 300 million years after the Big Bang, thousands of beautiful and very advanced galaxies were already in existence in the cosmos. Unlike the fossil galaxies, normal galaxies have undergone development since the early days of the universe. Stars were born, stars perished, galaxies migrated, and merged with others, thus repeatedly changing their appearance and shape. NGC 1277, on the other hand, has not formed any new stars for billions of years. The galaxy consists almost exclusively of old, metal-poor stars. The early universe was characterized by stars that researchers believed did not have a particularly long lifespan. However, NGC 1277 presents a different case, as these early light and metal-poor stars appear to be remarkably stable, reaching almost incredible ages. This suggests the presence of a previously unknown mechanism that may have frozen processes within the galaxy. Understanding this mechanism is crucial, as it could represent a force that initially promotes galaxy growth and then halts it, allowing galaxies to maintain their acquired forms. Notably, NGC 1277 hosts an extremely massive black hole at its center, accounting for about 14% of the galaxy's total mass, a fraction that is unusually high. There are additional peculiarities surrounding this black hole. Typically, it would need to consume significant amounts of the galaxy's matter over billions of years, leading to a reduction in size, especially if new stars are not formed. It remains unclear whether the mechanisms governing the black hole have reached a standstill. Interestingly, NGC 1277 is not situated at the center of a vast galaxy cluster. Instead, it is relatively isolated in a region of the universe with very few galaxies. Meanwhile, the James Webb Space Telescope, JWST, has made headlines with its discovery of an Einstein ring, a phenomenon that had long been a hypothetical concept. Albert Einstein predicted these astronomical objects, yet no one had observed one for nearly a century. Einstein rings are specific instances of gravitational lensing, forming a perfect ring rather than a magnifying glass-like arc. JWST has found a galaxy, SDSS J1226+2149, that features one of these rings, showcasing the telescope's exceptional capabilities in capturing faint emissions from distant space. The Einstein ring around SDSS J1226+2149 was created by light distortion from the galaxy, as an intervening galaxy cluster stretched and shaped the light into a ring form. This stretching not only produces a fascinating physical effect but also significantly magnifies objects located behind it, functioning similarly to a gravitational lens. The first Einstein ring observed was in the galaxy cluster AEL 370, which remains one of the most striking examples of a complete Einstein ring. This effect enabled astronomers to analyze the distant galaxy in detail, gathering insights into its structure and star formation rate. Beyond its aesthetic appeal, the Einstein ring around AEL 370 exemplifies the practical application of the general theory of relativity and its capacity to facilitate new astronomical discoveries. Thanks to gravitational lensing, astronomers have identified many distant objects, including GN-Z11, one of the oldest and most distant galaxies recorded. Located approximately 13.4 billion light-years away, GN-Z11 dates back to about 400 million years post-Big Bang. The lensing effect amplified the light from this galaxy, granting astronomers valuable insights into its structure and composition. Even the Hubble Space Telescope achieved discoveries through gravitational lensing, despite prior beliefs that it had reached its observational limits. Max J1149 plus 2223, the most distant individual star ever identified, was also uncovered through gravitational lensing. Situated in a galaxy around 9 billion light-years away, this star's light would have been too weak to detect without the lensing effect from a cluster of galaxies between it and Earth, which amplified the light by approximately 1,000 times. This allowed astronomers to study this distant star in detail for the first time. The ability to analyze individual stars from distant epochs is a significant achievement for scientists, and with the James Webb Space Telescope, we can dissect light signals from stars like Max J1149 plus 2223 to understand the elements and gases that comprised the early universe. Stay tuned to our channel for more exciting videos about space exploration and the latest astronomical findings.